Okay, hello, this is Dr. Janes, and today I've been talking about, I did about 3 episodes already of transistor oscillator, which is cool because you don't need a, an oscillator chip, and I mentioned some other reasons why I'm using that for my research. They don't have as much interference if you have some kind of signals that are interfering with low voltage oscillators. That you don't have to worry about that with a high power oscillator. And so I've been looking at getting the range tunability and putting this into a package. And, well, package will be the next step. This video is going to be about testing the circuit at high power to make sure that it's going to scale up to high power, because I want to really put a lot of power through this device. And so let's get testing. So anyway, here it is, the 2 transistor oscillator circuit. Okay, here we go. Looks like it finally arrived. Let's see what this is. Okay. Oh, wow. Okay, oh. Looks like there's a few different things in here. Let's see what these guys are. Also made in China. Okay, so this is what I'm going to need for my oscillator. My oscillator circuit over here. Because I found that the 10K was too big of a value. So let's take a look what we got here, huh? Okay. I guess this bag just opens up. These are 1K dual potentiometers with knobs and everything. Very cool, huh? So I'm going to have to replace the 10K that I have on my high power 2 transistor audio oscillator with these guys. Actually, that audio oscillator goes way up high enough frequencies to drive some Tesla coils too, so I might try that circuit for driving Tesla coils as well. But anyway, very cool, huh? I'll have to try these out. Okay. Okay, so I just changed the 10K potentiometer out of this guy for a 1K. It's a 10K. Say 10K in there? Anyway, it's a 10K one, yeah. For a 1K potentiometer. And I'm just testing out the frequency range. I'm using these capacitors right here. And looks like the high frequency range is 69 kilohertz. Okay. And I'll just bring down, also I reverse the polarity so that it goes to higher frequency when I twist it to the clockwise direction. Okay, let me see what the frequency is here. Okay, so this is kind of the lower end, and we're at about 13 kilohertz, so it's covering pretty much all the range that I want it to. And then it starts to become a little bit jumpy down here. I guess that you have to expect that when you're having an oscillator. It looks like we can get some frequencies lower, but it's jumping around a little bit when it goes down there, which is not the ideal case, but it looks like we can get a frequency of about 7.8 kilohertz. And I may play around with the capacitor combinations a little bit. There's a high frequency there that we're hitting. It seems a little bit unstable though. I don't know why. Okay. That's around 11 kilohertz. Okay, go a little bit higher, becomes stable again. That seems to be pretty stable in this regime. Let's see what that is. Okay, so about 13 kilohertz on up, I think it's pretty much stable. So 13 to 60 some kilohertz. Okay. It looks like our oscillator is behaving pretty good with a few jumps at the bottom. But I think that's acceptable. And I might play around with the capacitors a little bit more, but I think we're approaching a final design here that could be usable. Very interesting, huh? Okay, so I finally decided to go with 2 of these 10 microfarad capacitors. I got this off of Amazon. And, oh, okay, it's my capacitor kits. Got a circuit I'm working on. And, needed some 10 microfarad capacitors. And in the comments, I guess it's not written in the, in the main description of these guys, what's the breakdown voltage of these, or the working voltage, and they said it was 50 volts, and I think that will be acceptable for this application, but good to know. They should really tell you the voltage and the capacitance, because those are the 2 important factors in choosing a capacitor, right? Okay, let's check this out. Okay, so here's our little capacitor kit, and my high-power sound generator requires maybe about 10 microfarads. Well, it's not coming out of here too easily, is it? It's a nice little bag. I hate to wreck it. Come on. So I'm gonna come out the bag. There we go. Okay, so here is our capacitor kit, and let's open her up, see what's inside of this thing. Oh, I think it's taped, really. Maybe it's got plastic wrap around it. Ooh. Okay. Let's take a look in here. Come on. Oh, there we go. Okay. This product has passed inspection. Okay. And I guess they're labeled on the top. Which ones are which? These are the ones I'm interested in. They all look about the same physical size. These are supposedly the 10 microfarad ones. So maybe I will make a little incision in this bag here. And we'll test one of these out. There's a razor blade. See if they're really 10 microfarads. That is tiny for a 10 microfarad capacitor. This plastic is really binding up everything. It's really annoying. Okay, anyway, I guess they're not getting away. So there we go. Is that in focus? I don't know. 10 microfarad capacitor. Okay, here is our LRC meter, and I'll put it onto resistance. Okay, so let's see if this thing is really 10 microfarads or not. So we got our capacitor here, and we will try hooking up the clip leads to this. Okay, so it's claiming about 8 microfarads, which is, yeah. I guess close enough, because that's about what I was using before, is 8 microfarads. So well, even if I have to use a couple of them, you know, it was getting kind of bulky in my other circuit, because I'm using a whole bunch of these big capacitors, polyurethane, but they're probably rated for higher voltage. That's why you care about the voltage. And so we'll see how this works. See if we can get our circuit to work with these tiny little capacitors here. Okay. Should be interesting. I was trying to half this ohmage. I believe this is this is 100 ohms maybe. And when I did that, and put these high capacitors on there, I smoked my 1K double potentiometer, which really is annoying because I don't have that many of them. So this is double potentiometer again, so I'm tuning both sides of the oscillator circuit, one for each transistor. And so it actually pretty much covers the range that I want it to cover. I was hoping to maybe get it down to lower kilohertz range also, but it's not really stable down there with an inductive load. I did some quick tests with capacitor loads, and it is stable down with a capacitive speaker element, like one of these guys. So I'll probably do some videos with something like that in the future. But let's just test this. Okay, so I have my 3 18650 batteries, and be very careful not to drain them too much because it will destroy the batteries. Okay, so let's take a look. I have it hooked up to my oscilloscope, and anyway, the lowest frequency is about 9 kilohertz. Okay, and as I twiddle the knob, of course I can shift smoothly up to very high frequencies. I think the highest was probably about 75 kilohertz or something. Let me just take a look here. Let's see. So here is one period right there. So around 70 kilohertz for the upper end. And again, I was trying to add capacitance to this circuit to bring that down because I wanted frequencies at the lower end, but for some reason it becomes unstable and doesn't oscillate properly. And so I'm thinking this is a pretty good capacitance right there. Okay, so again, as I bring it down, we'll take a look here. See, it'll jump to a low frequency and it won't have anything in between those two. So it has one jump there, so the range is not continuous. So it's continuous down to about 9 kilohertz or so. I was hoping to get it, let me turn this off. I was hoping to get it continuous all the way down, but I think this is the best I'm going to do with this circuit. I'll be building some other circuits too. This one seems to be pretty nice so far. See if I can simplify this maybe. Anyway, very cool, huh? Okay, so here we go. I have my battery packs all hooked up, and I was expecting to get about 32 volts. Maybe some of the batteries are a little bit drained. I may have to charge them up. It takes a while to charge them because I can only charge them in pairs. But okay, so we have our 8 of them 18650 batteries in lithium ion in series. And according to my rough calculations, depending on what the actual impedance of this guy is, it claims it's 4 ohms. So if it really is 4 ohms, which I measured it to be about 6, if it was 4 ohms, it'll be about 250 watts. So it will be about twice as powerful as, I don't know if you've seen the video with this guy in it. This guy can only handle about 150 watts, and this guy can handle 300. And I don't want to go all the way up to 300 because I ran this one all the way up to 150 and I burnt one out. And so, okay, so we're going to do a full power test with 8 batteries on our oscillator, and we'll see how this thing behaves. Should be interesting. Okay. Okay, and of course I value my hearing, so I think I'm going to put some earplugs in. Squeeze them down at one end, stick them in, because this is going to be pretty loud. It's going to be close to, what, 300 watts, a single frequency. Should be interesting. Okay, so I have the black lead hooked up, and here is the red lead up here. Oh, come on. There's our circuit. Seems to be oscillating. It's got some jumps in the range at the bottom, but that's fine because I'm going to probably use it up toward the higher end anyway. And, ooh, I think I was smoking something. This potentiometer is not able to handle the power down there. Okay. Okay, I might have to do a redesign. Looks like our resistors are getting a little bit warm too. So we're putting a little bit too much power through this guy probably at full power level. Okay. I'll have to test this guy out, see if I smoked him, because there was smoke coming out of him. Okay. Okay, again, let's hook this guy up, and we'll look at it on the scope. It looks like the waveform's a little bit different now, but it is still, looks like it's square wave and still working somewhat properly at these high powers. Let me check the high frequency end of it. I'm going to unplug this guy. Okay, come on. So now it's only going up to about 15 kilohertz. I'm not sure if it's because I smoked my potentiometer or if it just behaves differently when it's at high power. So I'm going to have to maybe remove some of this. Remember, I put 20 microfarads in here, and maybe I'll put some higher resistance back in here because this is not good. Okay. So then I'll check out my potentiometer and see if I smoked it or something. So I'm going to have to fiddle around with this some more because going up to high power, it looks like the design has to be modified now. Okay. Anyway, lots of fun here. Okay, let's get going. Okay, so I did see some smoke coming out of this. Is my 1K potentiometer. And so I have my ohm meter hooked up to that. I'm just going to twiddle the values down. Remember, this is a dual one. I have to tune both sides simultaneously to keep the frequency together. And it looks like over this range so far, remember this is a 1K, it is working pretty good. Oh, there seems to be a jump there, so I think that's at the very end. Okay, so it looks like maybe down to about 300 ohms. We're still tuning okay. And it's going above 1K. It's about 1.4K at the very other end. Let me just check the other half of the potentiometer. And I may have to replace this later because it is burnt at the low impedance end. Okay, it's 1.2K. 1. I mean, the waveform was looking pretty symmetric on the O-scope. Okay, so 300 ohms. Okay, so this side is still good down to 100 ohms or so. And then it cuts out maybe 200 ohms, which may be okay, because I really am tuning it in the upper region here. And so maybe I'll take out some of the capacitance and maybe even put some higher resistance in here. I think these were 100 ohms. Originally I think I had 200 ohms in there. I could go back to 200 ohms. Taking out the capacitance is probably a more effective way to tune it though. So maybe I'll try to remove one of these 10 microfarad capacitors now that I've got this whole thing soldered up. Okay. And if I have to, I might replace this dual potentiometer again, because I already smoked one. Okay. Should be interesting. Okay, so I removed one of the capacitors, so now I have just a 10K in each side here. And I'll make sure these things don't short out. Touch them kind of close there. Okay, so I have my O-scope probe back on here, and my battery pack loaded up. And let's just turn her on. Oops. Flipboard's a little bit crappy. Okay, there we go. So there's our scope. Okay, so that's the highest frequency we can go to, but it doesn't seem like it's tuning as nicely as it used to. Let me just pause this guy. Oh, come on. Okay, so there we go. We're about up to 36 kilohertz at the upper end, but it seemed like it's not tuning as nicely as it used to. Let me fiddle around with this, and I may have to change the parameters some more. See what we can do about that. Okay. Okay, so I've tuned it down to the lower range, and now it's only going about 13 kilohertz before it jumps, and that could be partially because I think our potentiometer got smoked at the lower range, so it's got a jump there. So I may have to replace that. Maybe I'll try putting some extra resistance back in these guys, because they were getting hot when I was running it for a while before, and that might increase the tuning range up higher again to where we want it. We'll see. Okay, it looks like I have blown something else because the power level is very low now. The waveform is much smaller than it used to be, and it's not going over the same frequency range. And I don't know if I blew a transistor, or if I blew the speaker, or maybe the potentiometer is completely smoked. I'm going to have to, I think the battery pack, check that one. It seemed to be at the right voltage. So we'll have to troubleshoot this and see what broke. Okay, so it looks like the battery pack is at pretty much full voltage, 31 volts, so all the batteries should be good. And so there's not a lot of parts in this. I don't think we blew the transformer. I can check the resistances. Could be the potentiometer blew, or one of these transistors. Most likely one of these transistors blew, or maybe the speaker blew. I don't know. We'll have to check that out and see what's going on here. Okay, so let's test the inductance of this speaker here. And I'm getting an overload, which is not good. Okay, and there's no sound coming out of this guy. So I think, let me put this is a good speaker. Okay, and this is 58 microhenries, and it is making a normal sound. So I suspect that we have blown the speaker here, unfortunately. That's no good. Okay, so we'll have to see. I'm going to have to be more careful because I'm down to one speaker now. Okay, so it looks like I only blew out the speaker and my potentiometer again, and it looks like the transistors are still good. And I captured a trace at the low end. It's about 9 kilohertz, which is about as low as I ever got it to oscillate. and I have the 100 ohms and the 20 microfarads on each leg. And I think I'm going to have to go back down, even though the speaker says it's rated for 300 watts. I thought I was only putting in about 250 watts. Of course, that could be frequency dependent, right? But it blew out my other speaker, and so I think we're just going to have to go with a lower rated power level. And this is going to be something I use for my research. So I'm going to probably build a 3D printed container to hold this thing, so it'll make it more convenient to use. And it should be interesting. So I think this is going to be our final design here. And let's just, we'll turn the scope back on, and I'll just show you it's working again. Okay, so there we go. And turn it up to the high end and pause the scope. And I don't like to run this for too long, because remember, those lithium batteries, if they get depleted too much, they will be destroyed. I've already destroyed several of them. So let's see what the higher frequency limit of this design is. I'll just move it over here. Okay, so that's about 1 period. So 31 kilohertz. So I think that pretty much covers the useful range of our speaker here, because if I remember correctly, I think it had a resonance up to about 25 kilohertz in the ultrasonic. And then, of course, it goes down to about 1 kilohertz. I'm not going to be able to cover that for some reason. This circuit doesn't oscillate with an inductive load at that low of a frequency. So I think I'm going to start working to build a some kind of containing vessel to contain this whole thing. And so there's the conclusion of our high power testing. I tested it at twice, or it would have been 4 times the power, right? Because power goes as V squared. But it takes up a lot of resources. A lot of these batteries, you have to watch them all. And so I guess for a test unit, we'll just go with the lower voltage and not blow out our speaker, because this is our last one. And anyway, this is Dr. Janes, and thanks for watching. There'll probably be one more episode of this. I will do a 3D printed container and test this guy out, make it into a portable unit, like a flashlight or something. Be very cool. Anyway, hope you enjoy this. Should be very interesting. Okay, thanks for watching.